Let's start today by taking a look at our table of contents. So what we're going to do is we need to make sure that we have everything that's listed here. The commutative, associative, distributive on page 6, calculator basics, which is this document right here. You need to put that on page 9. You need to put the amazing operations with Alvaro looking for his cupcake on page 10. And then you need to have multiple representations, which we did on class or in class on page 11. And then these notes are going to be on page 13, translating into graphical representations. Today is translating into graphical representations. Your content objective is we will create and interpret graphs for real-world situations. Your academic vocabulary is continuous, discrete, positive, and negative. Once again, whatever goes on the screen needs to go in your notes, so please write down your content objective and the academic vocabulary. Line segments can do 3 things. The first thing that they can do, this first example that we see on the far left, this is a positive line. We see that it is increasing, so we're going to call it just that. We're going to say that this is increasing. So lines can be increasing, so logically, if this one is increasing, then we know that this next one should probably be decreasing. And that means that the last one is going to be constant because there is no change. We talked about that in class the other day. So what you need to do now is you need to come up with 3 other words that you can think of for each one of these. It can be a combination of words. So, good luck. Please recreate this graph in your notebook. You have an x-axis and a y-axis with time on the x-axis, temperature on the y-axis. Then what I want you to do is divide the graph up into 4 different sections. So we can see just by looking at this line that there are 4 different places, 4 different segments that we're talking about here. Here's 1, here's 2, here's 3, and there's 4. So what I expect for you to do is to be able to tell me what each one of those sections is, what type of line it is. Is it increasing? Is it decreasing? Is it staying constant? I'm going to give you a hint. Number 3, you see that it's that horizontal line. It's constant. You need to figure out the others. Here's example 2. So recreate this graph as well. You have your x-axis, y-axis, same thing as before, time and temperature. This graph has 1, 2, 3, 4 different line segments on it. So we're going to do the same thing as we did last time. We're going to draw those dotted lines up through those points. And I want you to label each segment as being positive, or increasing, decreasing, or constant. Now you have to pick which example fits the following description. The air temperature fell steadily, leveled off, fell again, and then increased slightly. What would be some key words that you should be looking at? Read the sentence maybe a couple times and figure out which one of those 2 examples, example 1 or example 2, fits this description. So we're either on page 14 now or we are on page 15. Make sure you do not go past page 15. So we have continuous versus discrete graphs. A continuous graph is a graph that you can draw without taking your pen or your pencil off the paper. So that means it includes fractions and it includes decimals and stuff like that. Basically, if you can start it in one spot and wherever you end it, you didn't have to take your pencil off the paper, then it's continuous. A discrete graph is just the opposite. You're going to have to include, or you're going to have to take your pen or pencil off the paper in order to create a discrete graph. With continuous graphs, you could say that you have 1.5 of something. With discrete graphs, unless that's a specific point, you can't include it. Some things that are continuous would be time, temperature, and distance. All of those need to be continuous. Some things that are discrete are people. You can't include half of a person. Animals. My favorite example is that you can't buy a third of a puppy. And objects. Those are all discrete. Now I want us to make a graph for this example. So we have example 3. The heart rate of someone walking, then running, and then resting. I'm going to need to label each one of my axes with some sort of title. So we know, let's go ahead, we always know time should be on the bottom. And then on the side, since we're talking about a person's heart rate, we're going to go ahead and put heart rate on the side. So now we need to think, what's happening here? If someone's walking, then they're running, and then they're resting, what's happening to their heart rate? We know that they're not starting out with a heart rate of 0, because if they were, they'd be dead, and that's not possible. So we'll go ahead and we'll say that their heart rate is maybe at this point right here. When they start walking, their heart rate's going to increase because they went from a period of rest to now they're exercising. When they start running, what's going to happen to their heart rate? Is it gonna go flat across? Is it going to decrease? Is it going to increase faster? The correct answer is increase faster. We know that when somebody starts running, their heart rate is going to jump up really quick. But then when they start to rest again, the heart rate's going to slow back down. So that is our graph. So here's example 4. You should pause the video and start copying down the example as well as trying to recreate the graph. Don't worry about making every single horizontal and vertical line. As long as you get a good idea for where they go, that's fine. So we know Ivy is selling ice cream. Each ice cream costs $1.50. She has 6 ice creams to sell. So what we need to do is we need to find points and plot them on this graph. So what I want to know is, if she has 6 ice creams, what's the maximum number of ice creams she could sell? It's 6. So if we have 1, 2, 3, 4, 5, and 6. So we'll say this is our number, and then this is going to be our money. So if she sells 1, she's going to make $1.50. If she sells 2, she's going to make $3. 3, 4, 5, 6, and so on. I want you to fill in all of those points to make sure they're all represented here on the graph. But if we start plotting this, if 1 is $1.50, it's going to be right about there. And then 2 is going to be $3. The question I really want to know is, should we connect this line? Is this going to be a continuous graph, or is it going to be a discrete graph? I want you to have that answer for me when you come in on Tuesday. That's it for now, but be sure to check back before you come to class on Friday. You're going to have some more notes that you need to take for that class. Thanks. Bye.